Okay, we're going to continue on with a little bit of math and physics, things like that. So today we're going to be talking about rearranging equations, and rearranging equations is really pivotal. It's phenomenally important in physics. And so we're going to talk about it before we even really start talking about physics. I mean, the last few days we haven't truly talked about physics at all. And so what we're going to be doing is we're going to be focusing on today rearranging mathematical equations. All disciplines of science, physics, chemistry, and biology require the use of mathematical equations from time to time. We're going to take some time getting the basics for rearranging equations. So sometimes we call rearranging equations, sometimes we say that as isolating for a variable. That's kind of the typical way that we explain that. We say that we're isolating for a variable. Now, before we start isolating for a variable, we need to make sure that we know what we mean when we say like opposite operation. So an opposite operation can be used to cancel out an operation in math. Well, what is an opposite operation? Well, we're going to kind of focus on that right now. So what is the opposite operation of the following operations? So multiplication. So, when we multiply something, let's say I went 3 times 5 or something like that. Let's say I wanted to do the opposite of multiply by 5. What's the opposite of multiplying by 5? Yeah, you're right. Totally. It's division, right? So when you divide by 5, that's the opposite of multiplying by 5. Well, what about addition? What's the opposite of addition? If I had, $5 and I added $100, what's the opposite of adding $100? Yeah, totally. It's subtraction. So it's important for us to know that these opposite operations exist because we're going to be using them shortly here in a second. If I square something, let's say I went 3 to the power 2. Well, that's 9, but how do I do the opposite of that? What's the opposite of raising to the power 2? Well, some of you got it for sure. That's a square root. So when I go 3 raised to the power 2 and then I square root that, the square and the square root cancel and I'm just left with the 3. So that's going to be important for us to be able to focus on the next set here. Let's use the opposite operation to isolate for x in the following equations. So if I have x here, x minus 7 equals 4. Now, some of you intuitively know how to do this, and that's because you're kind of math naturals or you have enough experience. But what I want you to focus on is I want you to focus on, we've got an x here, and what is happening to the x? Right now, we're subtracting 7. What's the opposite of subtracting 7? Adding 7. That's right. So if I had x minus 7 equals 4, if I wanted to get rid of the minus 7 on the left-hand side, I just need to add 7 to both sides. You can think of an equation a lot like a seesaw. Okay, so you got people on both sides of the seesaw. Oh, that's terrible. Holy guacamole. Now, if I add 7 people to the left side of the seesaw, I have to add 7 other people to the right side of the seesaw in order to make sure that they're still equal. An equation means the left side is equal in value to the right side. So if I add 7 to the left, I have to add 7 to the right. Now, whenever I perform an opposite operation, I go minus 7 plus 7. So if I took x, and if I subtracted 7 and then immediately added 7, that's like I steal $7 from you and then I immediately give it back. What happened? Well, they canceled each other out. and we're left with just our x. So we just have x on the left side of the equation. And on the right side of the equation, we've got our 4 plus 7, and 4 plus 7, hopefully we're okay with that being 11. Okay, hopefully that was all right. So an opposite operation can be used to cancel out something that's being done to a variable. Over on the right-hand side here, we've got x being divided by 3. Well, what's the opposite operation of dividing by 3? Multiplying by 3. So if I take this and if I multiply by 3, and I'm actually going to write that. I'm going to write that in a different way. If I take this and I multiply this side by 3, then I have to multiply this side by 3 as well. Well, let's try this. Let's go 3 times x and then immediately divide by 3. When you multiply by 3 and then immediately divide by 3, those processes, they cancel each other out. So what are we left with on the left-hand side? Well, the only thing we're left with on the left-hand side is x. On the right-hand side, 5 times 3 is 15. And so isolating for a variable, really all isolating for a variable is just trying to move everything other than the x from one side to the other. You're trying to isolate for a variable. And when you isolate something, it's left all by itself. You see how the x is left all by itself? If I drew a dotted line down the equation, the only thing on the left-hand side is the x, and everything else was moved to the right-hand side. That's what we need. Okay, here we go. X squared equals 71. Well, what's happening to the x? Is the x all by itself over here? Is it? Really? No, it's not. It's not all by itself. If it was all by itself, you would only see an x, but I see x squared. So what operation can we use to get rid of the square? Well, I can't divide by 2, because if I divide by 2, the square and divide by 2 don't cancel out because they're not opposite operations, so that's not going to work. I can't subtract 2 because subtraction and addition are opposite operations. What was the opposite operation of squaring something or to the power of something? Yeah, it was square root. So if I square something and then I immediately square root it, they cancel each other out. And the only thing I'm left with is the x. But whatever I do to one side, I have to do to the other. What did I do over here? I square rooted it, so I have to square root this side as well. So what I'm going to do is I'm going to pull up my illegally downloaded calculator, and I'm going to take my calculator, and let's go ahead and let's plug in the square root, so second x squared, which is square root of 71. And let's go ahead, 8.4261449, blah, 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 blah. Okay, no problem. So this is 8.426 something, 8.426, blah, 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 blah. But whenever I perform an operation, I have to take the same number of significant digits. So this number has 2 significant digits. We need 2 significant digits. And so the 2 will not round up the 4. So we just get 8.4. Perfect. So our x is equal to 8.4. Now similarly, if the square root of x is equal to 2.3, is my x all by itself? No, it's not. Our x is not all by itself. So what's the opposite of square rooting? Well, that's right. It's squaring something. Whatever I do to the left side, I have to do to the right. So I got to square it. So the square and square root cancel, and I'm just left with x. And if I do the same thing on my calculator, clear, and I'll go 2.3, and I'll raise it to the power 2. Here's a square button. 5.29. So our answer is 5.29, but it's not really. Our answer is not really 5.29 because I see 2 significant digits here, so I need 2 significant digits here. So we're going to round 5.3 because the 9 rounds the 2 up to a 3. So our x is 5.3. Perfect. I'm writing on a slant. Uh-oh. So in science, a lot of the time, what we want to do is we want to rearrange an equation before we start putting in information. A lot of the times maybe you're in your math courses, you'll put in the numbers for variables and then you'll rearrange. But in science, we like to rearrange first. And so what we have is we have an equation here. Our equation is v equals d over t. So what we want to do is we want to solve for d. So we want to get d all by itself in the equation if v is equal to 60 and t is equal to 5. Well, what we could do, if we wanted to, we could put the values into this formula and then rearrange. But in science, we don't like doing that. And the reason why we don't like doing that in science is because when you get to higher levels of science, things get a lot simpler if you wait to put the numbers in until the very end. If you keep the formula the way it is and just rearrange using the variables, things get a lot simpler and they stay cleaner and less messy. And maybe you don't believe me, but that's okay. Just try it and maybe you'll see where we're going with this. Okay. So what we want to do, solve for d. So when I say solve for d, that means we need d all by itself. Well, what's happening to d? What operation is happening to d? d is being divided by t. Well, what's the opposite of dividing by t? Timesing by t. So if we multiply by t, if I were to divide by t and then multiply by t all in a row, do them at the same time, they cancel out. It's like cutting a cake in half and then doubling the cake that you cut in half, so you get a whole cake again. They just cancel each other out. So what are we going to be left with? Well, on the right-hand side, what's the only thing that's left? D. On the left-hand side, we've got t times v, and I'm going to write it as v times t for no reason other than I just like it. Now, there's no reason why we have to say vt equals d. We could write this as d equals vt. Just because something's on the right-hand side of an equation, I mean, you can swap the entire right-hand side with the entire left-hand side. It just means this side's equal to that side. That's all. So d equals v times t. We've got our new formula now. And when we're rearranging equations in science, it's really important that you give us the rearranged version. Often we will mark you. Your questions will be at a 2 or 3, and you'll get a mark just for giving us the rearranged version. And then you'll get another mark for substituting the values in. So we know what v is. v is 60. So d equals 60 times t, which is 5.0. So you get another mark just for kind of substituting the information in. It wasn't really difficult, but you had to do it. Because part of our science courses is communicating how we got the answer. And so now all we have to do is go 60 times 5. Well, 60 times 5 is 300. So d equals 300. Perfect, but not quite. If you're happy up until here, then that's great. And we'll get used to using scientific notation in significant digits. But right now I want to stress that when we're multiplying, we always take the lowest number of significant digits. How many significant digits are here? 2. 60 is 2 significant digits. How many significant digits are here? 2. 5.0, the 5 and the 0. So if I have 2 digits times 2 digits, I have to take the lowest number. They're the same, so 2. So here are my 2 digits. Notice that it doesn't include the decimal place. So what we have to do is we are forced to use scientific notation. Now, in order to use scientific notation, we move the decimal place till it's behind the first significant digit, so 3.0. And how many times did you move it? 1, 2, times 10 to the power of 2. Perfect. I got that slanty box going on again. Oh well, that's okay. So let's move on to the next one. I kind of promised myself that I would make this video short, and so far I'm not really living up to it. Sorry. Okay. So the next one, v equals d divided by t. Solve for t in the equation if v equals 1.3 times 10 to the 2 and d equals 450. This one's a little bit complicated. I want to be very clear. If I want to solve for a variable, the variable should be in the top of a fraction. Okay? I can't solve for t when it's in the bottom of a fraction. And so what you have to do, I know this is a little bit backwards, we've got to do a little bit of work before we can really kind of think of this as an equation that we can solve. If your variable is in the bottom of a fraction, then multiply both sides by that variable. So this multiply by t, and then multiply by t. So we're going to get t times v equals, and the t cancel, and we get d. So now that there's no fractions, this is way easier to solve for. So if you ever see your variable that you want to isolate, if it's in the bottom of a fraction called the denominator, then multiply both sides by that variable. And it will cancel on the one side and reappear in the numerator of the other side. Okay. So t times v equals d. We still want t by itself. So what's happening to t right now? It's being multiplied by v. Well, what's the opposite of multiplying by v? Dividing by v. Dividing by v. So if I take t and I multiply it by v, then divide by v, well, multiplying by something and dividing by something, they cancel out. So what are you left with? You're left with t equals d over v. So now that I've got that rearranged equation, that's one of those marks, I'm going to continue on over here. So I'll just rewrite it. T equals d over v. And then I'm going to substitute my information. Do we know what d is? Yeah, it's 450. Do we know what 1.3 times, or do we know what v is? Sorry. V is 1.3 times 10 to the 2. 1.3 times 10 to the 2. So now I can just plug this into my calculator, and then we can calculate what the value of t is. Now I'm going to show you on a bunch of different calculators how to calculate the value of t. So here's our rearranged equation, and we're worried that people are going to put this into their calculator wrong, because as you can see here, there's a number that is using scientific notation. Now, whenever you put a number into your calculator that has scientific notation, what we don't want you to do is we don't want you, for example, to put in the number like this, 450 divided by 1.3 times 10 to the power 2. And the reason why we don't want you to do this is because you're going to get the wrong answer. Now, this number basically is 450, but down here, that number 1.3 times 10 to the positive 2, that's really just 130. Now, if I use the 1.3 times 10 arrow up button, then I get a value of 34,615. Now, I'm pretty sure when I take 450 divided by 130, I shouldn't get 34,000. I should get 3.46. And so something's wrong here. Whenever you have a number that's using scientific notation, don't use times 10 to the power of. Every scientific calculator, every graphing calculator should have a very specific number that's used for scientific notation. And I've got a bunch of different examples here. So here we're using a Texas Instruments TI-30X2S. I'm just going to clear the data right now. And so the very specific button that we should be using, instead of times 10 to the power of, is a very specific button, and it's right above the x to the power of -1. It's written in blue letters, and it's EE. So the way I would put this on my calculator, instead of going 1.3 times 10 to the power 2, I would go 1.3, and because it's written in blue, you have to hit the second button. So now I have second, the function is activated, and I'm going to hit x to the -1, which means EE. That EE stands for times 10 to the power of. So now I just have to put in what my exponent is, 2. We already know that this value should be 130, and when I punch that into my calculator, that is in fact what I get. I get 130. So in order to do this calculation properly, we go 450 divided by 1.3 times 10 to the power of. Remember that EE represents times 10 to the power of 2. And that's what our answer should be. Our answer should be 3.4615, blah, 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 blah. But if we're going to round this, to 2 significant digits, we'll round it to 3.5. So we know our answer should be 3.5. Now I'm going to get a bunch of different calculators, and we're going to try this on some different calculators. On the TI-30X2S, it's an EE button. And that should be the same as our graphing calculators. Our graphing calculators, there's an EE button here. So we would do the same calculation, except it's written in yellow. So we write second EE for times 10 to the power of. That's not the same thing as every calculator. Here we have just kind of a Staples brand calculator. So when I turn this on, if I want to do this calculation, I don't see an EE button, but I do see EXP. That EXP means times 10 to the power of. So 450 divided by 1.3 times 10 to the power of. See, they're using the E. That's the same thing as the Texas Instruments. And then to the power of 2. 1.3 times 10 to the power of 2. So should be 3.46, which we've rounded to 3.5. We've got one last example here. Here we have a Casio, and it's kind of similar to the Staples brand calculator, where down at the bottom, instead of an EXP button, we've got a times 10 to the power of button. And so we'll use that, times 10 to the power of. So turn it on, 450 divided by 1.3 times 10 to the power of 2. And here we get our 3.5 again. So just try and make sure, use your specific calculator. Sometimes if you continually have problems, sometimes the best bet, like for example, this Texas Instruments calculator, even though it has a times 10 to the power of something button for 450 divided by 1.3 times 10 to the power of 2, we're still getting the wrong answer. And that's because this calculator is thinking that the 1.3 times 10 to the power of 2, it thinks of it as 2 separate numbers. So what we have to do is we have to go in and we have to actually put brackets around this. So the entire number at the bottom, we have to put brackets around, and that's how we're going to get our 3.5. Okay, so we went over how to calculate the value of t here. And remember, just keep that in the back of your mind that anytime we have a number in scientific notation, we absolutely need to use that special button on our calculator, or else you're just going to have to use brackets. If you really persist on actually writing out, 1.3 times 10 arrow up 2, right? If you're going to do that on your calculator, you got to put brackets around it, because you got to tell your calculator that this whole thing is just one number, right? Okay, so this, when we calculated this, the value of this was 3.5. Perfect. Rounded to 2 significant digits. So we'll keep on going. We're going to rearrange a few more equations. EP equals MGH, and this MG and H, they're all different values, but EP is just one number. It stands for potential energy. So solve for M. This is the thing that I want to get by itself. In the equation, if EP is 40, G is 9.81, and H is 0.50. Okay, no problem. So EP equals MGH. Well, what's happening to the M? What's going on? What mathematical operation is happening to the M? Well, the M is being multiplied by G and H all at the same time. You can think of it as being EP equals M times G times H. Well, in order to get the M all by itself, you're going to have to perform the opposite operation. What's the opposite operation of multiplying by G and multiplying by H all at the same time? Dividing by G and H all at the same time. So whatever I do to one side, I have to do to the other. The G and the H cancel with the G and the H, like the G and G cancel, the H and the H cancel. And so what are we left with? We're left with M on the right-hand side, and it's equal to EP divided by G and H. So that's my rearrange. I'm gonna go ahead and write that in a different way. I'm very used to putting the isolated variable on the left side of the equation. So M equals EP over GH. So let's go ahead and put in our values. M is equal to 40. EP is just 40. And then G is 9.81. And H is 0.50. And let's go ahead and calculate this. Now I want to be clear again. Every time you go to use your calculator, you got to use it properly. So if we're going to go 40 divided by two numbers, there's two numbers that we're dividing by. If you're dividing by two numbers, you have to put brackets around it. So 40 divided by 0.81. And then on the bottom, there's also 0.50 end bracket. So I've got 40 divided by both 9.81 and 0.50. And on the bottom, they're multiplying each other. So when I do this calculation, I get 8.1549 blah, 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 blah. 8.1549 blah, 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 blah. And I look at how many significant digits. Well, over here, I've got 2 significant digits. Here I've got 3, and here I've got the 0. Leading zeros aren't significant. So I've only got 2 here. So take the lowest number of significant digits, 2 of them. Now look at the next digit is a 5. It's going to round that 1 up to a 2 because 8.15 is closer to 2 than it is to 1. So the actual answer that we're going to report is going to be 8.2. That's the actual value of m. Good. Couple more. Solve for v in the equation here. And so what we want to do is we want to kind of work outside to in. We want to go like the opposite of our order of operations. If you're isolating for a variable or if you're rearranging an equation, you want to do the opposite of the order of operations. And so, well, I could do exponents first, but I don't want to. I want to do exponents almost last, okay? Remember our order of operations? BEDMAS. So addition and subtraction, division and multiplication, exponents and brackets. So you want to do addition and subtraction first. I don't see any addition and subtraction, so don't worry about it. Division and multiplication. Okay. If my v is right here, I want to get it by itself. What's happening to the v? Well, it's being squared, it's being multiplied by m, and it's being divided by 2, all at the same time. So what we're going to do is we're going to, instead of divide by 2, we're going to multiply by 2. So we're going to multiply by 2. The 2 and the 2 cancel. We're going to divide by m. The m and the m divide by m. They're going to cancel. So on the right-hand side, I'm left with v squared. On the left-hand side, I have 2ek over m. And so now we want to get rid of, so now we're done with multiplication and division. Now we'll deal with our exponent. So instead of squaring, what's the opposite of squaring? Square rooting. So the square and the square root cancel. Whatever you do one side, you got to do the other. So my rearranged equation, v, right, v is all by itself now, is equal to the square root of 2 times ek over m. Holy guacamole. Don't worry about it today. We're just getting used to rearranging equations. We're going to get practice with this later on in the semester, okay? We're going to get lots of practice with this later on. This is a particularly complicated equation. This is one of the most complicated. So 2ek, well, what is ek? ek is 50, so I'm going to put 50 in here. Divided by m, what is m? It's 4.0. So when I do this, okay, I'm going to bring up my calculator, and I'm going to go, okay, the square root, where is it? Square root of 2 times 50, 2 times 50 and divided by 4.0 and enter is 5. Ooh, 5, perfect. So in here, remember the 2 originally came from the formula, so that's a definition, that's an infinite number of significant digits. So this 2 is an infinite number of significant digits. The 50 is 2 significant digits, the 4 is 2 significant digits, so I got to round this to 2. The only way I can round it to 2 is by putting a 0.0 on the end. That's what v is equal to. Whoo! Okay, let's keep going. One more. Solve for vf in the equation if a equals 8.0, t equals 2.0, and vi equals 10. So here we're looking for VF, that's what we're looking for. Now we want to work outside in. Hopefully you can see the t is dividing both of these things. So I'm going to multiply by t, cancel, and multiply by t. So I have t times a is equal to VF minus VI. That's a terrible VF. So I want VF all by itself. What's the opposite of subtracting VI? Adding VI. So I got to add VI to both sides. So I get VF on the right-hand side, and I get T times A plus VI. And so you should know how to do this, or you should be able to plug in the additional information here. VF is equal to T times A. Well, T is 2.0 times A is 8.0, and I'm adding the VI is 10, so plus 10. 2 times 8 is 16, 16 plus 10 is 26. And I've got 2 significant digits, so I'm happy with that. Perfect. What I want you to do is I want you to pause the video right now, and I want you to try the practice questions on the next page. Try the practice questions out as best you can, and then unpause the video to look at the solutions if you want, or you can just look at the filled out notes to see how I solved them, okay? There's no assignment necessarily today, and we're going to be starting physics properly tomorrow. And we're going to be using all of the tools that we've learned so far. Significant digits, scientific notation, conversions, unit conversions, and now rearranging equations. And we're going to be using all of these tools every day. And trust me when I say it's going to get easier and easier and easier as time goes on. So pause the video, try the next few questions, and let me know if you have any questions. Okay, we're going to go over the solutions to the practice problems now. So solve for D in the equation. So I want D, and we're dividing by T, so I'm going to multiply by T and multiply by T. So D equals V times T, or T times V, doesn't really matter, V times T. Now I'm going to put what V and T are. V is equal to 7.0. and T is equal to 2.5. So that means 7 times 2.5 is going to be 17.5. No problem, 17.5. Now, keep in mind, 2 significant digits here, 2 significant digits here, so we need 2 digits here. So actually the 5 is going to round the 7 up to an 18. So we could just write that. It's actually 18. Perfect. Okay, let's move on. Solve for T in the equation if V equals 6.3 times 10 to the 2 and D equals 3.27 times 10 to the 3. This is going to be a little bit ugly. We've got this equation here where the unknown variable that we want is in the bottom. And remember, if something's in the bottom, you multiply by that variable. So multiply by T, I get D on one side is V times T on the other. And so I still want T, but now it's been moved to the top of a fraction because everything can be written as divided by 1. Just dividing by 1 doesn't do anything. So we want T and we're being multiplied by V. How do you get rid of multiplied by V? Well, you divide by V. So what we're going to do is we're going to divide by V, cancel, cancel, divide by V, and we're going to get T equals D divided by V. Perfect. T equals D divided by V, and D is 3.27 times 10 to the power 3. On the bottom, 6.3 times 10 to the power 2. And I'm going to bring up my calculator and just make sure that we all know how to do this. So 3.27 times 10 to the power of, right? 3 divided by, and there's only one number on the bottom, so that's good. 6.3 times 10 to the power of 2. All right, here we go. So that's 5.19047, blah, 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 5.19047, blah, 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 blah. We want to round. We've got 3 significant digits on top, 3 significant digits on top, but on the bottom we've only got 2 significant digits. So we're going to take 2 significant digits. So the real answer here is 5.2. Hopefully that makes sense. Moving on. EP equals MGH. Solve for H in the equation if EP is this, G is this, and M is this. Perfect, no problem. So we want H. Remember, H is being multiplied by both M and G. So what I'm going to do is I'm going to divide by M and G. Cancel, 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 cancel. Got to divide by M and G. So EP over MG equals H. No problem. So let's just substitute in these values. EP is 2.5 times 10 to the 2. M is 17.0. G is 9.81. And so if we do this calculation, bring up my calculator, 2.5 times 10 to the power of 2 divided by, there's 2 numbers on the bottom, so I have to use brackets. 17, I'm not going to put 0.0 because it doesn't matter, at least for the calculator, 9 times 9.81, bracket, enter, 1.49907, blah, 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 blah. 1.49907. So let's think about this. We've got on top, we've got 2 significant digits, 3 significant digits, and 3 significant digits. So I'm going to take the lowest number, 2. So this is going to be, the 9's going to round that 4 up to a 5, and we're actually going to get 1.5. That's going to be our answer for H. Next one, solve for M in the equation if EK equals 300 and V equals 6.72. So we want M, so here's M, so we have to multiply by 2, cancel, cancel, so multiply by 2. And then we have to divide. M is being multiplied by V squared, so we got to divide by V squared, divide by V squared. So M on one side, and then 2EK over V squared. So 2EK, we know what that is, that's 300. We know V is 6.72, and it's being squared. So let's go ahead and put this into our calculator. Move it off to the side. We've got 2 times 300, divided by 6.72 squared. Nope. Squared. Perfect. Okay, 13.2865 something. 13.2865 something. And I'm going to round. 2 is a perfect number. It's a whole number, so it's infinite significant digits. So this number is infinite significant digits. This number is 3 digits. This number is 3 digits. So I'm going to take 3 digits. And so we're going to need to rewrite this as 13 point. The 8 rounds the 2 up to a 3. Last question, last problem. Solve for VF in the equation if A equals 1.5, T equals 50, and VI equals 18. So we already know how to do this. So VF is here, so we got to multiply everything by T. T and T cancel, so we got T times A equals VF minus VI. And then I want VF, so I'm going to add VI, so we got TA plus VI equals VF. So what is that? T times A. Well, T is 50, A is 1.5, and I'm adding 18. So what's this going to be? 50 times 1.5 is 75. 75 plus 18 is 93. Perfect. Hopefully that helps. Let me know if you have any questions. Come see me in the office hours. Ask a question on the questions document. So far, nobody has asked a question on the questions document, and I've had very few people talk to me in the office hours. But I am here to help you. I hope you have a good day. See you later, Science 10.